We're right. All right, we'll get back underway.
Yeah, one that still works.
Yes, yeah. Scott made a comment earlier on that we hadn't sacrificed the goat to the demonstration gods. So fingers crossed. Across to Scott.
Cool. So I have been building slowly over a period of a month or so a beacon to transmit FSQ using 2 parts and about $20 worth of gear. So I thought I'd just sort of start off because although a few of you do turn up on the FSQ net which we run on Friday nights, there's plenty here that don't, so there's a chance to get a few more people into this thing. So FSQ is a digital mode that has been only around for a couple of years. It's similar to PSK31, but in the fact that it's 3 to 6 board, and it's just a series of tones, and it works pretty well on upper sideband. So it's created by Murray Z1BPU. I don't remember his last name. And basically
Greenman.
Greenman. Okay. Yeah. And so it's got letters, numbers, and some additional characters. It doesn't have the full ASCII character set, as I found out. And it uses 1 to 2 tones to actually generate a character. And the interesting thing is that uppercase actually requires 2 tones. So people who set up FSQ call or FLDigi and put their call sign in uppercase, it takes longer to transmit. So the first thing we do is tell them to change their call sign to lowercase. Yeah. But that being said, if you've used PSK31, this is where it gets a bit different. Whereas PSK31 in FLDigi, at least you're there and you're seeing the letters come across the screen, and then they finish transmitting and you start typing away there straight away. FSQ has the idea of automatic triggers. So Tom's left his computer on the home, man.
I have.
You have? Yeah. I could go and transmit VK7NTK question mark, and his station will automatically respond with a signal report. So don't even have to be at home to do it.
Which is really handy.
Really nice, yeah. Which is basically got my head around the idea of this. Beacon might be really good to set up something automatic. Yeah. But it can do a few more other things. If you want to see what stations that Tom has heard, you just type in VK7NTK app, and it will respond with a list of stations that's heard recently in timestamps. So you can actually see what stations you've heard and compare it to Tom's list, Ian's list, and see which stations you can't hear. Because the next feature, which is the one I really like, is relaying. So in our weekly net, I'm out in the middle of nowhere, over there, that way. And I have a Yagi pointing back into Hobart, and I'm going to get back on HF this weekend. So Tom is in Lena Valley, Ian is down in Kingston. I can't hear Ian at all. I hear Tom. So I can relay a message to Tom by going to Ian by going VK7NTK semicolon VK7IS. How's the weather down there?
What band?
Whichever frequency you both agree on. We on Fridays do 2 meters, 145.225 upper sideband at 8 o'clock, and then we switch to 7105 kilohertz on at 8:30. So the 7105 is the main calling frequency. So and then Tom will actually transmit that line, and then it'll be able to hear my message. You can respond in a similar way back. So we can have an entire conversation. We can't actually hear each other.
How many relays can you put in there?
We haven't tried any more than one, but we can try a few more this Friday.
Just wondered.
I wonder if.
That's impressive.
I wonder if how smart it is if it goes in a circular. See if we can trick that this Friday. We'll put that down as the theme. You can also, you don't even have to be there. This is the other reason why I kind of wanted a beacon is I could put a beacon on there, or I could actually put a really low power transmitter and have them around my property. Like it's just 4 to 10 milliwatts. And I'll be able to probably receive that at my house. And I can have a weather station on it. And so I call VK7LXX Station 7. It goes back to my house, and I want it to append some telemetry from weather station. And it will actually append that data to weather.txt, and then my station will automatically respond with an acknowledgement. Tom wants to see what the weather is. Sorry, I'm using it as an example of this one because what the weather is at my place. He can actually request the weather file, like with the plus command, and it will then transmit the file. So it doesn't even have to be a radio to do half of this stuff, but it's kind of cool. So, and so as you can probably guess, there's a whole bunch of automatic things you can do with it, and a beacon's automated. But I wanted to do it as cheaply as possible because I'm spending all my money on other things, other radios.
More expensive SDRs.
Which will turn up one day. I wanted a simple project that I could perhaps do in 1 or 2 weekends. I wanted to basically turn a couple of bits of hardware and write a little bit of software and turn it into a software-defined radio application. So this is a software-defined radio that can only transmit in 4 modes. As you'll find out soon. I like building kits. I'm slowly getting better at it. Maybe not tonight. This one's a bit intermittent tonight. And you can never have too many side projects. So the bit that I'm using, and I will tempt the gods here, is this. This is the Adafruit SI5351 breakout board. So it has a clock generator. The clock generator can actually generate 8 independent clocks. Only 3 are wired up on this breakout board, but that's 3 is more than enough. I'm using 1. And it basically does you configure it with I2C, which is a digital protocol. So it's basically 4 wires going back to an Arduino Nano, which I'm using here, and a power supply on the side. So that is the breakout. 3 clock generators. Yes. What can it transmit on? 8 kilohertz to 160 megahertz. So perfect for a lot of the HF bands, even up to 2 meters. So.
Okay to ask a question?
Yeah.
Oh. On the 5351, is that what suffix is that? Is it A, C?
I think this is the A. No. Yes, A. Yes.
That has an onboard crystal at 27 megs.
The breakout has a TXCO on it. So
Right. The reason I was asking is because there's one of those versions. This was something I was thinking about with Rex, telling Rex about it. I believe in one of the versions, maybe the C version, you can have an external oscillator which is 10 megs. And the thing about it is all 8 of those are numerically divisible.
Yes.
So I got rid of it, but I could have had a 31.2 megahertz oscillator based on 10 megahertz going into my 2-meter rig, that kind of thing. So that's available now. I mean, from Arduino, from Adafruit.
Well, I know. This breakout board only uses the A. I don't think it uses the C. So it's only what the onboard oscillator is using.
Yeah, there is one of the crystal pins you can overdrive with the 10 megs and then use that instead of the crystal. So it's a different division base, but you can get anything you want. You like it? Does it work well?
It does work well. I thought it was drifting, but it turns out it's just the crappy RTL SDR that was warming up and drifting off. So, so yeah, let me hopefully.
What does that cost?
So it was. I'll get to that.
Oh.
15 Australian dollars, $7.95 US. If you go from 80 but Tronics Labs in Melbourne sells those for $15. And they have them in stock right now. They have about 6 or 7 in stock, so it was great. I could just go straight there, and I got it sent in 3 or 4 days. And Arduino was in the shed. So the Arduino project is actually, if you go into the Arduino IDE and you go to the Manage Library section and you search for EtherKit, there's 2 libraries. One is SI351, the other one is JC Encode. And that's pretty much what I'm using here, because yes, you can pretty much, with a few lines of extra code, you can reconfigure my program to transmit JT9, JT65 and this way. That's Beacon, so yeah. So the output of this the output can be 2, 4, 6 or 8 milliamps output, and I've got a 5-volt Arduino there, so I'm using on the lowest setting 2 milliamps. That basically means about 15 milliwatts. So I thought, no one's going to hear me out of Buckland with this little beacon. Even if I ramp it up to 8 milliamps, it's only 40 milliwatts of power. So there's a $50 2-meter amplifier kit from MiniKits there, which include. I went to MiniKits basically to buy a filter to filter the square waves from this into, just to filter out the harmonics. But ended up buying this 8-watt amplifier with a filter onto it. So for just another $25. So 8 watts. People should be able to hear me at a bucket. The only downside it is, and the reason why this is not connected right now, is that it requires 5 milliwatt inputs maximum, and so the lowest setting you can do on that is 2 milliamps output, which basically means 15 milliwatts. So I actually have to
Attenuate.
I have to drop that a little bit. And so, but there is space on this surface mount thing to put a couple of resistors to make a little pi attenuator. We did a calculation, and unfortunately I don't have any surface mount 39 ohm or 150 ohm resistors right now. And you have to, if I was going to order those from Element 14 or something,
No,
have to get.
don't worry, Scott. We can get them.
Yeah, that's what I thought.
We got 'em.
Does anyone have some of these? I just thought I'd bring it, and I can finish this and I can put it on.
You don't have to surface mount, you don't need surface mount.
The space that's right here for them,
Yeah.
it would be a lot better, easier for them to be surface mount. I'll put it in a box one day as well, that's the other thing. So I was going to show you some code, but I'll have to do that in another window. And the internet goes away.
Always doing this.
Never did. Don't find that.
Yeah.
No, it's not that.
It was that before, Tom. So yeah, valid comment.
It's just resolving hosts.
Yeah. When it went to sleep and came back, it's. Right, I'll come back to that slide in a little bit because there's other stuff to cover. This one. So that was the first half of the project. Quite easy to set up. Nice weekend. I've got it transmitting VK7LXX no call hello world every 10 seconds right now on that. And yeah, leave it there, right there. Maybe space it out a little bit so I'm not transmitting quite so noisily. But that's transmitting on 145.225 right now. So, but as I come back to the triggers which I talked about before, it'd be really good if this project could receive FSQ and then transmit its reply out of this little Arduino based SDR that I've got. So for that I kind of just went back to the shed and got an RTL SDR dongle and a Raspberry Pi right here. Yeah, let's hook it up. But I could write a FSQ decoding application using GNU Radio and get all complicated like that. But I didn't really want to go there yet. It's GNU Radio's kind of confusing, and I'd have to Google a lot and things like that. So what I've done is I've set up so I don't have to plug this into a TV all the time. I've set it up with the remote VNC server so I could get the remote desktop over the network, and I've installed GQRX, which, if you have a look over here, is this window. I'll show it to you on here, but it keeps crashing, which is why I have it on this one. So that's just a generic receiver for the SDR dongle, and then we're using FLDigi. Now FLDigi, you normally need a sound card. You take your the input to FLDigi is the microphone and speaker in your sound card, and you connect that up to your radio. Well, the radio's in the computer here. It's in a USB dongle. So how do we get that? In Linux, really easy to get a loopback sound device. So you can connect the GQRX application into the FLDigi application as a virtual sound card. So in that case, once FLDigi is run, well, it doesn't know how to transmit out my little FSQ Arduino beacon here. The Arduino beacon is connected to the Raspberry Pi using a serial port, so USB serial port. So I need a Python program, which actually runs a simple Python program. It just has two lightweight threads and listens on one thread for and polls the FLDigi application for has it received any new data, and then if it has, FLDigi is basically telling it to transmit. It sends that data to the other thread to send to the serial Arduino port on the serial to actually do the transmission. So and it's really this is kind of where I ran into a little brick wall, but FLDigi has an interface. You can connect to it via Telnet or and send it some XML and get responses and actually control FLDigi completely without actually being in FLDigi. How do we do this magic? To do. Oh no. This is my to do. I've done it. Right here. So I have FLDigi here, not connected to anything because for some reason GQRX keeps crashing on this computer at the moment. So as I said, did not sacrifice anything to the demo gods tonight. Everything's breaking. But so you just run that program, leave it alone. I have this thing called the Jupyter Notebook. If you're learning Python, it's a really good way to actually write notes about it, because you can code Python in the web page and then run it and rerun it and demonstrate it to people later on. So I just import the FLDigi library and create a client. So if I click that and press run, it's just created a connection to FLDigi, like the app running in the other window. If I type in FLDigi modem.names, it will actually give me a list of modes and return a list of modes that FLDigi can handle. So on any other day, I could type in fldigi.modem.name equals feldhelp, and it would change mode remotely, essentially. In this case, you can query what current mode it's in by typing in fldigi.modem.name, and it will respond, I'm in the FSQ mode at the moment. One thing that we've had a little bit of trouble with FSQ is that you have to have everything, the tones appear in this line here, in this, for it to do a proper decode and for the data to appear up the top. And everyone's radio at 2 meters seems to be a little bit high or a little bit low. And so half the net is about, oh yeah, I'm a bit high, okay, I'm coming down a bit. And then it's suddenly 8:30 and we all go to HF. And we don't have that
And
problem.
it doesn't matter.
But yeah, so I've decided that I need to go down 200 hertz. Tom, you need to go up a little bit, don't you? No, you're just. We also.
It depends who's complaining most.
Yeah. So, and that's this number down here. What the center frequency is here. So I can actually control that remotely by changing that there, fldigi.modem.carrier. If I run that and go back, you'll see it's actually changed that number down there, so you can actually remotely control FLDigi. And you want to get, so the idea of this is, I want to get the data that's in that top box when it appears. And that is actually quite easy. It's the bottom line here, FLDigi get RX data, and that will return the data that's in the receive box. And I can just go fldigi.text.transmit, and if I had actually a real transmitter on it. But in this case, I can do get TX data, and because FLDigi wants to respond automatically with those signal to noise reports, the SNR reports, it's going to put it in this box. So I'll go get TX data, and it will return the contents of this box, which is empty at the moment. But and then I can send that text to the Arduino, and it will transmit it. So using a Raspberry Pi to receive and an Arduino to transmit, put a bit of electrical tape around it, and I've got my beacon. Yeah. So that's where I am at the moment. And if you have a look at here, this beacon is actually transmitting right now, and you come across and have a look at it, and then if you go to FLDigi, the FLDigi window, which I can't show you on here, is basically just saying BK7LXX hello world. So that's my, if I put a bit of code, extra code in there, I can actually transmit what I want, and then I'll look it up to 8 watts, and there we go. Yeah, so this is what I've still got to do. I have to process the triggers and respond to them, so that's just a little bit of Python code. Look that up in the afternoon. Right now I've got 2 antennas on this, but it'd be really good to put it on a transmit relay, so I could just put it with 1 antenna. It's got 3 independent clock outputs, so I can hook up another clock output to HF and put a HF filter on it, maybe an amplifier on that, and do an FSQ beacon on HF. So that's then I'll need another SDR to receive it. I don't know. It's work in progress. Yeah, and as I said, this is about $20 worth. You can get the Arduino Nanos for about $5 on eBay, and $15 for the clock generator. You just put them at 2 or 4 or 8 milliamps output, so 16 to 40 milliwatts output. Just put them around different places, and have them as transmitting telemetry of how much is raining, what's the weather like, what time is it. Just have it sending that all back to your home station. Yeah. And the other thing which you can do is actually add GPS to it and turn it into a whisper beacon. So I'll probably do that one weekend. See how far I get. Yeah. Let me see if this. So you've just got to set up a few parameters in there. I've got the JT9, JT65 stuff in there already, but this is mostly actually copied and pasted from the example sketch, which you get with the EtherKit library. So out of the box it does Whisper. I've just changed the code to make it do FSQ. And so you basically give it a mode, tell what mode it's in, and it will change the spacing there for you. Right at the start, you initialize the clock generator, set the power that you want to output. We encode the message, hello world. Put to the destination call sign is no call at the moment, but it could be anything. And transmit actually, so the encode message actually turns the text into an array of the two tones that I need to send for each character. And so then when and that puts that in a big long buffer, and then the transmit function actually takes care of the transmitting. So yeah, I could just change set mode to be something else, FSQ 6 board, FSQ 4.5, 3 board, or Whisper, and press the reset button, and it will start transmitting in a different mode. So yeah, and as I said, that's just an example code, so you can then, even if you don't know a lot of C or Arduino, just try changing a few variables and reloading and see what happens. And plug it into an SDR so you can actually see what it's transmitting as well. So, or have your radio nearby with FL Digi running so you can see if you're receiving. So right now, at the moment I've had this beacon running, I'm actually, all of my stuff just comes up on the screen on my main desktop. But it doesn't come up as a successful decode because I am not sending the right character between the colon. I thought it was a space, but it's not. I think it's A4, byte called A4 instead. If that, I need to go and change that, and it will actually then do a proper decode.
So how are you actually modulating? Is Arduino just stepping the clock frequency just by the tone?
Yeah, so
command, is it?
in those two, it's basically, let me have a look at the
Toggling the output pin. Toggling the output pin at the right frequency.
Changing that is hard. Yeah.
Um, so there's there's 8 hertz between the two tones.
Yes.
And so you're basically sending one tone, waiting a very short time, and then changing the clock frequency to send those 2 times, and waiting the delay. In this case, 167 milliseconds for FSQ 6, up to 500 milliseconds for FSQ 2.
Yep.
And then you're just changing the frequency of the clock by sending it commands like so it's up the top.
Set
I'm
frequency.
setting the frequency
Yep.
to be, the frequency is actually it's a unsigned long, so it's a 64-bit long integer, which is so 100, which is its resolution is down to 100th of a hertz, so two decimal places. So yeah, times it by 100 to get what you want there. The tone which you want to send plus times the spacing and which clock you want to send it out, and then you're waiting for delay, and then once you finish sending, you turn the clock off. So clock enable with 1 will turn the clock on, clock enable with 0 will turn the clock off.
There you go.
Yeah, thanks.
So yeah. Yeah, and so there's different functions to encode the message in whatever method that is included in the library. Yeah, with almost no change of code. So yeah, that's what I've been working on. I should have it finished once I get some resistors.
Fantastic. Any questions for Scott? Okay, fantastic. Thank you, Scott.
And so I'll see you all on FSQ Friday.
See you here. 2 metres or 40 metres?
Yes.
So you've got a choice.